Hello guys, my name is Pratyush Jain, and in this demo video, we are going to talk about some basics related to the topic called time and work. As you guys already know that if you're preparing for any exam that has general aptitude or quantitative aptitude as a subject, then the topic of time and work becomes very important. And if you're able to understand the basics, if you're able to grasp the concept, then not only this topic becomes easy, it also becomes scoring. So you can score a very good amount of marks in this topic. So with that, let us start the topic of time and work. So the first thing that we talk about in this topic is the nature of the questions. How do we define a particular problem or a particular question belongs to this topic called time and work? So in any time and work question, there are three elements that are always involved. The first is some work, some task that has to be done, that has to be performed. The second thing that a time and work problem has or consists of is time. Some particular time is given. It can be in seconds, minutes, days. The amount of time or the unit of time does not matter. What matters is that some time is given within which the task or the work has to be performed. The third thing that is given is some entities, some people who perform this work, who do this work. It can be laborers, it can be daily wage workers, it can be your employees, it can be anything. These persons or these people, they perform this work. So whenever these three things are involved, whenever these three elements are involved, we say that this particular question belongs to time and work. All right. Now suppose we have a person A. This A completes a work in X days. Now we have a person, someone who is performing a work. We have some work. Basically, we are given that some work has to be completed. So we have some work and we have some time, X days. So we have all the three elements. So this statement belongs to time and work. Now we say that this person A completes an entire work in X days, right? So A's daily work or per day work will be 1 by X. If A can perform one entire work in X days, so every day he will perform 1 by X amount of work. That means if every day he performs 1 by X amount of work, then 1 by X plus 1 by X plus 1 by X. Every day for X days, if he does this, he will complete the work, right? Suppose similarly, we have another person B who can complete the same work in Y days. We have another person B, he can complete the same one work in Y days. So B's daily work will be similarly 1 by Y, right? If B performs 1 by Y work, amount of work on first day plus on second day plus on third day, then in Y days, he will complete the entire work. He will complete the task, right? So if we say this, then if we are asked what is the per day work of A and B if they work together, suppose A can independently complete the work in X days, his per day work was 1 by X. B can independently complete the same work in Y days, his per day work was 1 by Y. So for A and B, if they work together, then their per day work will be simply per day work of A plus per day work of Y, sum of their individual per day works, which is nothing but equal to 1 by X plus 1 by Y, right? So we get to the first formula in our topic, which is per day work of A and per day work of and B, if they work together, is nothing but sum of their individual per day works. 1 by, in this case, 1 by X plus 1 by Y. Now also note this, that the per day work of any person is denoted by small letters or lowercase letters. So in case of A, A's per day work is denoted by or is denoted as small a, and in B's case, it is denoted as small b. right? So here per day work of A and B, if they work together, will be sum of their per day works, which is equal to 1 by x upon 1 by y, which is equal to small a plus small b, where small a is A's per day work and small b is B's per day work. All right. Now here we say that small a, which is A's per day work, is equal to 1 by x. Small a is per day work of A. X is the total time taken by A, right? Similarly, small b or B's per day work is equal to 1 by y. So the thing we notice here is per day work is equal to 1 upon time taken to complete the work. For A, per day work was small a, which was equal to 1 by x, where x was equal to the total time taken by A to complete the work. So small a is equal to 1 by x. Similarly, for B, it was small b is equal to 1 by y. So the formula we note from here is that per day work is equal to 1 upon time taken to complete the work, right? Now let us say that time taken by A and B together to complete the work. If A and B work together, then they complete the work in, let's say, T A plus B time. Let's say we use this variable T A plus B to denote time taken by A and B if they work together to complete the work. So using the above formula, using this formula that per day work is equal to 1 by time taken to complete the work, we say T A plus B is equal to 1 by A plus B. Time taken by A and B if they work together is equal to 1 upon their per day work, right? Which is equal to 1 upon A plus B. Their per day work of A and B if they work together is nothing but the sum of their individual per day works, which is equal to small a plus small b. So we get the formula T A plus B is equal to 1 upon A plus B. I hope this is clear. This is the basic formula that we use. This is the basis of our entire topic of time and work. If you're able to understand how this formula has come into picture, then the entire topic of time and work is within your grasp. Let's understand this with a small example. Suppose, question number 1. Suppose we have a person A who can complete writing a book in 8 days. There is a person A, he can write an entire book in 8 days. Another person B can write the same book in 10 days. B takes 10 days to write the same book, right? How long will it take for them to complete the book if they work together? If A and B work together, if A and B start writing the book together, how long will it take for them to complete the book? Now here, notice that we have work is writing a book. We have some time, 8 days, 10 days, and we have some people A and B who do this work. So it is a time and work question. That's the first thing that we notice, that all right, it is a time and work question. Now we say that A's per day work or small a is equal to 1 by 8, right? 1 upon total time taken by A, which was 8 days, so 1 by 8. Similarly, B's per day work or small b is equal to 1 by 10. B takes 10 days to completely write the book, so 1 by 10 is his per day work. Now if A and B work together, their per day work will be simply sum of their individual per day works, which is equal to small a plus small b, which is equal to 1 by 8 plus 1 by 10, that is 9 by 40. So time taken for them to complete the work will be 1 upon their per day work, which is equal to 40 upon 9 days. We use this formula we just derived. We just understood how this formula comes, right? The time taken is equal to 1 upon per day work, or per day work is equal to 1 upon time taken. It is the same thing. So we use this formula here to solve this question. Okay. Let's look at another question. Raju can construct a wall in 15 days. There is a person, Raju. He takes 15 days to construct a wall. Raju and Arjun can construct the same wall in 10 days if they work together. If two people, Raju and Arjun, if they work together, they can complete the construction of the same wall in 10 days. How long, the question says, how long will it take for Arjun to construct the wall if he works alone? If Arjun works alone, how much time will it take for him to construct the wall? That's the question, right? So I am given that Raju's per day work or small r is equal to 1 by 15. 1 upon time taken by Raju alone, that is 1 by 15. I am also given Raju and Arjun's time, which is 10 days. So their per day work will be simply 1 upon 10, which is equal to small r plus small a, the sum of their individual per day works. So I am given Raju's per day work. I am given per day work of Raju and Arjun working together. So I can find out Arjun's per day work, which is equal to r plus a minus r. 1 upon 10 minus 1 upon 15, simply 1 upon 30, right? We can do this calculation. So we have small a is equal to 1 by 30. Basically, Arjun's per day work is 1 by 30. Now I know per day work is equal to 1 upon time taken by that person to complete the work. So time taken by Arjun if he works alone is simply 30 days. Simple. Now, notice this. In this question and in the question before, we had a lot of fractions involved. 1 upon 15, 1 upon 10. We have a lot of calculations involving fractions. 1 upon 10 minus 1 upon 15. In the previous question, 1 upon 8 plus 1 upon 10, things like that. So not only fractions take a lot of time to get solved, but also there is a very good chance or very likely possibility that some errors are made while solving them. You never know when you solve them incorrectly, right? So it's always risky, or there is always a possibility that some error is committed while solving for these questions when fractions are involved. So what we do is we learn an alternate method. We understand an alternate method to solve these questions which do not involve fractions. If we can simply eliminate somehow the fractions involved, a lot of calculations will become simpler. So not only will we save a lot of time, we will also reduce the chances of us committing some errors. In the paper, there is a lot of pressure on us. Not only do we have to solve the question correctly, we also have to solve them within a given amount of time, 1 to 2 minutes normally, right? So we have a lot of pressure on our minds that we have to solve this question and we have to solve it correctly and we have to solve it within a decent amount of time. So it's always a good thing if we can learn some new method, some simpler method, which not only increases our chances of solving the question correctly, but also can save us some precious seconds, right? So we look at an alternate method. What is this alternate method? Understand this. What we do is we take our work, whatever work was given to us, and we divide it into a number of subunits. We take our one work, whatever it was, whether it was writing a book or whether it was constructing a wall or whatever it is, we take that one work and we divide it into some subunits, right? Some sub blocks of some sub works. Instead of one whole work, we say that now we have to perform some x sub works or x smaller units of work, right? Some smaller blocks of work instead of entire work. Basically, we break our work into some smaller sub works, and instead of completing one entire work, we say where we have to complete some multiple or more than one smaller works. Understand this with an example. In our example one, we said that a book had to be written. We had to write a book. A could write it in 8 days and B could write a book in 10 days, right? So we said that one book was to be written. Now, instead of one book, we say that one book has P pages. One book is equal to P pages. For, for the time being, forget what the value of P is. Let's just focus on that. Yes, some P pages are to be done. Some P pages are to be written, right? So we divided our one book into some smaller units we called pages, right? So now one book is equivalent to P pages. Whether we write one book or whether we write P pages, it's the same thing, right? So now our task is to write P pages and not one book. They both are the same thing. Whether I say that I have to write one book or whether I say that I have to write P pages, it is the same thing, because one book is equal to P pages. I have divided, or I have broken my one book into P pages, right? Now, in my example, instead of saying one book, we say that A can write P pages in 8 days instead of one book, and B can write P pages in 10 days. So A's per day work will now be P by 8 instead of 1 by 8. 1 by 8 was 1 by 8th part of a book. Now here it is P by 8 pages, right? Similarly for B, it will be equal to P by 10 pages instead of 1 by 10th part of a book, right? So here we have successfully managed to break our one work into some smaller units of some sub work. Instead of one work, now my focus is on P. Instead of one book, now my target is P pages. So whatever the value of P is, if I can successfully choose some value of P such that I can convert my P by 8 and P by 10 into numbers, into rather than fractions, into some whole numbers, then my task of removing the fraction is achieved, right? The the entire point of learning this alternate method was that I had to deal with some fractions which could increase my chances of committing some error. So I had to find a way such that if I can remove these fractions, if I can solve my question without involving fractions, then that would be great, right? That I did by dividing my work into some smaller subunits. So I say that instead of one book, now I have P pages. So A's per day work is P by 8 and B's per day work is P by 10. Now, if I can choose some value for P such that P by 8 and P by 10, they both become some whole number, then that would complete my task. Then that would complete my aim of removing fractions permanently. How do we do that? We choose this value P, or we break our work in some subunits in such a way, in such a manner that this value of P will be LCM of time. If I can take it simple, if I assume my P as LCM of 8 and 10, then P will be divisible by both 8 and 10, right? In this case, P will be LCM of 8 and 10, which is equal to 40. So if I say that the book had 40 pages, then A's per day work will be 40 by 8, that is 5 pages. Every day A can write 5 pages. He has to write a total of 40 pages, which he can write in 8 days. Similarly for B, it will be 40 upon 10, that is 4 pages per day. So in 10 days, he can write an entire book consisting of 40 pages. So in this manner, I have successfully managed to remove fractions as a whole from my method, from my solution. Understand this from this table. What we do is, while solving my question with this method, what we do is we draw this table. We draw a table. In my first column, I write person. In second, I write time. in third I write work, and in fourth I write per day work. So for person A took 8 days to completely write a book, and person B took 10 days to completely write a book, right? Now in my work, I say I'm not writing one book. I am writing some pages, P pages. And this P is equal to nothing but LCM of time. So this P is equal to 40. So instead of writing one book, I say I am writing, or A and B are writing 40 pages, right? So my per day work is now basically my total work upon total time, which is equal to 5 pages. If A can write 40 pages in 8 days, so every day he can write 5 pages. Similarly, every day B can write 4 pages. So instead of 1 by 8 or 1 by 10, now my per day work is 5 and 4, whole numbers instead of fractions. And A plus B, which is equal to, if A and B work together, if A and B write this book together, then their per day work will be simply equal to 5 plus 4. Sum of individual per day works of A and B, which is 5 plus 4 is equal to 9. Instead of 1 by 8 and 1 by 10, now I have to simply add 5 and 4. How simple is this, right? So every day A and B together can write 9 pages, right? And they have to write a total of 40 pages. So per day work is basically pages written per day instead of amount of book written per day. Instead of fractions, it is simply pages written per day, and entire fractions and ratios are gone now, completely gone. So A and B's per day work is simply now 9 pages. And we know, we have already understood that per day work is nothing but total work upon total time. Earlier, my total work was one book, but now my total work is 40 pages. So simply, if per day work will be 9 for A and B, per day work is 9 pages, total work is 40 pages. So time taken will be simply equal to total work upon per day work, which is 40 upon 9 days. Right? Let's take another example using this method. In the question, we are given that A can do a work in 20 days. There is a person A who can complete a work in 20 days. He works for only 5 days and leaves. He could have completed the entire work in 20 days, but he only works for 5 days and then leaves. Says Tata bye bye. The rest of the work is done by B in 10 days. Whatever work was remaining, it was done by B alone in 10 days. So the question asks me, if A and B work together, how much time will they take to complete the work? If A and B had worked together, then what was the amount of time they would have taken to complete this work? Right? Again, I will draw the table. I am now using the new method. Right? The new method says I have to draw a table. First will be person, time, work, then per day work. Right? So person is, I have A. Now total time of only A is given to me in the question, that A can complete a work in 20 days. I am not, but how much time B takes to complete the entire work, that is not given to me. Only A is given to me. So I will only take A, right? So work, I will simply say LCM of time, which is 20 in this case. Rather than one work, again, I have divided my, or I have broken my one work into some smaller parts, which is nothing but equal to LCM of time. In this question, the total time of only A is given to me, that is 20 days. So I will simply say that my work is 20 units, which is LCM of time. So per day work for A will be 1 unit. If every day A performs 1 unit of work, then in 20 days he will perform 20 units of work, right? So we are only told about total time of A, so we only consider A. So work done by A in 5 days will be his per day work into number of days, right? in 5 days he will perform 5 days worth of work, which is simply his everyday work into number of days. So which is his everyday work is his per day work is 1 unit into number of days, which is 5. So 5. So A has performed 5 units of work and then he leaves. Right? In 5 days, he does work for 5 days and then he leaves. So A works for 5 days. He completes 5 units of work and then he leaves. So work remaining is total work minus work done by A, which is equal to 20 minus 5, 15. So 15 units of work is now remaining. This remaining work is done by B, right? In the question, we are said that A can do a work in 20 days. He only works for 5 days and leaves. And the rest of the work is done by B in 10 days. So this work is done by B in 10 days. So B's per day work will be small b is equal to work done by him divided by number of days. So 15 upon 10, which is equal to 1.5. So every day he can do 1.5 units of work. So again, we draw this in this table. We say that we had 20, we had work 20, and we had per day work of A. Now we have per day work of B, 1.5, right? So we can find out per day work of A plus B simply is equal to 1 plus 1.5, which is 2.5. So for A and B, A plus B, we have their per day work. We have the total amount of work they have to complete. So we time taken by A and B together will be what? Total work upon per day work, right? Which is equal to 20 upon 2.5, which is equal to 8 days. So A and B together can complete the entire work in 8 days. So I hope that this video is long enough and I have been successfully able to teach this newer, faster method, simpler method for the topic time and work. Thank you.